Last main example in 3.3 day 2 is about analyzing a log function. And again, when I say analyzing, that means finding certain special characteristics that we have for that particular graph. Here's my function that I want to use, and this is definitely okay to just pop it in the calculator in order to see what it looks like. So, got that entered in. I'm going to go to Zoom Standard for now. Here's something important that I want to mention about the graphing calculator. You'll oftentimes see graphs cut off like that. This is simply a calculator error. It should be going down. It should be reaching down further on this one. So I'm going to just draw a version of this graph over to the side here. This graph really goes down forever in that area. So it looks more like this when we're talking about the graph of this function. So don't be deceived by the fact that the calculator cuts it off. It's just basically because it doesn't have enough pixels to be sharp enough. If you're ever wondering about it, one thing I would highly recommend is that you go on Desmos and give it a try. That should clear up any confusion because Desmos has a lot more pixels to work with. It's just a little bit more precise than your TI calculator. So I would highly recommend that you double check that if you ever see a graph that looks suspicious on your calculator. Now that we have that though, let's take a look at these different pieces to analyze. Now I didn't really specify how far we went over, but it looks like if you have x plus 1 in the middle, that means that we went over to the right by 1, and so that means that, or excuse me, the left by 1, so that means that our vertical asymptote is going to be x equals -1. So that is right here with this graph. Horizontal asymptote, one thing I mentioned in an earlier video is that this thing right here looks like it's leveling off, but it actually doesn't. It keeps going up forever. So there is no there is no horizontal asymptote, and that's the case for every single log function. So never think of horizontal asymptotes when you're thinking of log functions. They just don't happen. This one, is it increasing or decreasing? It is in fact increasing in this case. It's going up forever. The domain starts at the vertical asymptote, goes over forever in direction of the right in this case. So the domain here is going to be -1 to positive infinity. It is a rounded bracket here because it doesn't quite reach that value. It doesn't quite reach the asymptote, as is the case with asymptotes. Next is the range. As I mentioned, it goes from all the way down to all the way up, so our range, and this is probably the most commonly missed feature of a natural log graph, is that it's negative to positive infinity. Extrema, mins and maxes, doesn't have any. There are no mins or maxes in this. It just keeps going in one direction forever. Continuity, is this thing continuous? Can you draw the whole thing without lifting up your pen or pencil? The shorter answer is yes. The little bit longer answer is yes over the entire domain. Now there are some parts of the graph that this thing doesn't exist. It gets cut off right here and it doesn't go to the left, so that's the only reason I mentioned that part. Symmetry, there is none. It's not symmetric through the origin. It also isn't symmetric over the y-axis, so there's no symmetry here. Here's another little tricky thing about this is end behavior. Let's start with the one that's not too bad, and that's over here. What happens as we go to the right forever? So we're looking at left and right. As we go to the right forever, this thing, like I mentioned, keeps going up. So it goes to positive infinity. Now this is the tricky one when it says as x approaches negative infinity. Well, this graph isn't going to have the chance to approach negative infinity because, at least to the left anyway, because it stops at x equals -1. There is no end behavior on this one, and so the best we can say is does not exist. So those are all the main components or main characteristics that I'd like you to know about log functions. The ones in your assignment will look really similar to this, only with a couple of little changes based on the specifics of the function.